You think you understand time. You wear a watch. You feel yourself getting older. Minutes turn to hours. Hours turn to days. But that's not time. That's a biological trick your brain plays on you. School told you time flows like a river. Teachers nodded. You wrote it down. But here's the thing. If time is a river, how fast does the river flow? 1 second per second? That's meaningless. That's like saying a table is 1 table long. Time doesn't flow. Time doesn't push you anywhere. Time doesn't make you age. Your watch isn't measuring some cosmic stream. Your watch is lying to you. And when you see what time really is, when you really understand what's happening, you realize something that should break your brain. Twins can meet as strangers. Same birthday, different generations. One remembers the other as young. The other sees someone older than their parents. This isn't science fiction. This is physics. And once you see it, you can't unsee it. Let me show you. Let's start with what goes on inside your brain, because that's where all the confusion begins. Try something right now. Try to count to 60 seconds in your head. Just sit there and count. 1, 2, 3. Now, here's what's interesting. Some of you, when you count, you hear a voice, an internal narrator, a little speaker inside your head going 1, 2, 3, 4. Others see something completely different, a tape measure clicking along, numbers appearing visually, dots on a line, a counter incrementing. #! META, quote, pause, quote, colon, quote, sex, quote, colon, 1.0. 2 people, same task, completely different internal experiences. Here's where it gets fascinating. The person who counts with a voice, the one who subvocalizes, they can't read a single word while counting without losing track. The moment they try to read, the voice gets hijacked. The counting stops. But the visual counter, the one who sees the tape measure clicking, they can sort socks while counting perfectly. They can do visual tasks and still keep track of the numbers because they're using a different mental system entirely. This isn't just a quirky psychological fact. This is telling you something profound about what you experience as time. What you just felt, that sensation of 60 seconds passing, that wasn't time. That was your brain constructing an illusion, a biological hallucination, a model, a guess. And here's the thing that should disturb you. Your model is specific to your neural architecture. The voice person and the visual person aren't experiencing the same thing at all. They're running different software. They have completely different internal representations of what they call 60 seconds. So which one of them is actually experiencing time? Neither. Both are experiencing their brain's best guess about time. A useful fiction, a biological hack evolution gave you for survival. Your brain doesn't have a clock. It has a crude timer cobbled together from whatever cognitive systems were lying around. Some people got the voice version. Some got the visual version. Neither is measuring actual time any more than a sundial measures the rotation of the Earth. The shit meta. 1.0. This matters because when we talk about physics, when we talk about what time actually is, we have to throw your brain out the window. Your feelings about time are useless here. Your intuitions are wrong. Your internal experience is a hallucination. We have to start from scratch. We have to stop asking how time feels and start asking how we measure it. What operations do we actually perform when we claim to know what time it is? This is the Feynman approach. Don't ask, what is the essence of time? That's philosophy. Ask instead, how do we measure it? What do we actually do? Here's what time actually is. At META, second, 1.0. Forget the flowing river. Forget the cosmic stream. Time is just the ordering of events. Think about it like this. Imagine you have a deck of cards spread out on a table. Each card is an event. This card is your alarm going off. That card is you eating breakfast. Another card is you reading this right now. Time is the table. Events are the cards. When we say time passes, we're just reading the cards from left to right. First this event, then that event, then the next one. An ordering, a sequence. Newton thought time was something separate from the events, a background stage on which everything happens, a container that would exist even if nothing was inside it. That view is completely wrong. Time is not a background stage. Time is not a container. Time is a measure of change. And here's the key insight. If absolutely nothing in the universe changes, if no atoms vibrate, no light moves, no particles decay, no thoughts occur, then time stops. Not time continues but nothing happens. Time itself ceases to have meaning. Picture this: every atom frozen, every photon suspended in mid-flight, every electron locked in orbit, every thought halted before completion. No vibrations, no decay, no change of any kind. Is time passing? The question becomes meaningless. You can't ask how much time is passing if there's no change to measure. It's like asking, how many inches is silence? The question doesn't make grammatical sense, but more importantly, it doesn't make physical sense. Time isn't a background hum. Time isn't some cosmic metronome ticking away regardless of what's happening. Time is the change. No change, no time. This is why physicists talk about time so differently than you and I do in everyday life. We say, time made me older. Time caused the milk to spoil. Time heals all wounds. Wrong, wrong, wrong. Time didn't do anything. Chemical reactions made you older. Bacteria spoiled the milk. Biological processes healed your wounds. Time is just the bookkeeping, the ordering system, the ruler we use to say, this happened before that. Saying, time did it, is like saying, inches built your house. Inches didn't build anything. Carpenters built your house. Inches just tell you where the walls are. They're a measurement, not a cause. Time is the same thing. A measurement, not a force, not an agent, not something that acts on you. Just a way of ordering events. Now, your intuition is going to fight back here. Hard. You're going to say, but I feel time passing. I feel myself getting older. Surely time is doing something to me. Remember the counting experiment? Some people hear a voice. Some see a tape measure. Both swear they're experiencing time passing. Neither is. Your sense of time flowing is that same biological hallucination. Your brain constructing a narrative. Useful for survival, completely misleading for physics. Your intuition is going to fight back here. Hard. You're going to say, but I feel time passing. I feel myself getting older. Surely time is doing something to me. No. Time isn't doing anything to you. Look at your hands. See those wrinkles forming? Those gray hairs? That's not time's work. That's chemistry. Proteins breaking down. DNA copying errors accumulating. Telomeres shortening. Time didn't cause any of that. Chemical reactions did. Think about it this way. If you could freeze every chemical reaction in your body, every molecular change, every electron shift, would you age? No, you'd be frozen, unchanging. And what we call time passing for you would be meaningless. Time is the scorecard, not the player. We say time heals all wounds. Wrong. Your immune system heals wounds. White blood cells, collagen formation, tissue regeneration. Time just sits there, counting the events. We say time erodes mountains. Wrong. Wind erodes mountains. Water erodes mountains. Ice cracks rock. Time is just the ruler we use to measure how long the erosion took. Hashed meta. Pause. Sex. 1.0. This is a hard habit to break. Our language is built around time as an actor. Time flies. Time drags. Time waits for no one. But time doesn't fly or drag. Your brain's dopamine levels change. Your attention shifts. Your internal model of duration stretches or compresses. And time? Time just keeps being what it is. A dimension, a measurement, a way of ordering events. So we've established that time is just a ruler, a measurement system, a way of saying, this happened before that. But here's where things get truly strange. What if I told you that ruler isn't even fixed? What if your ruler and my ruler measure different lengths? And we're both right. We used to think a second was a second, anywhere in the universe, for anyone. Absolute, fixed. Universal. It feels obvious. It's completely false. A second for you sitting still is not the same as a second for an astronaut traveling at half the speed of light. Not metaphorically, not perceptually. Physically, measurably different. Let me show you why. Imagine you're driving a car across a giant flat sheet of paper. The paper stretches infinitely in all directions. You can drive north. You can drive east. You can drive any direction you want. Now here's the key. Your speedometer is stuck at 100 miles per hour. That's it. You can't go faster or slower. 100 miles per hour, always. If you drive purely north, all 100 miles per hour goes northward. Maximum progress north. But what if you turn your wheel? What if you start driving northeast? Now you're sharing your speed. Some of that 100 miles per hour is going north. Some is going east. You're still moving at 100 miles per hour total. But your northward progress has slowed down. The more you turn toward east, the less you're progressing north. This is exactly how space-time works. Replace north with time. Replace east with space. You are always moving through the universe at a constant speed. Think of it as the cosmic speedometer. It's stuck. It never changes. But that motion is shared between space and time. Right now, sitting still, reading this, you're not moving through space. Zero spatial velocity. Where is all your motion going? Into time. 100% of your cosmic velocity is carrying you into the future at maximum speed. You're aging as fast as possible. Now stand up. Walk across the room. You just stole some of your motion from time and gave it to space. Imperceptible? Yes, but real. Measurable. The faster you move through space, the slower you move through time. Your motion through time has decreased. Your clock is ticking slower. Not because the clock is broken, because time itself is passing more slowly for you. At walking speed, the effect is impossibly tiny, billionths of a second over your lifetime. But speed it up. At 10% the speed of light, about 67 million miles per hour, or 108 million kilometers per hour, the effect becomes noticeable. Your clock runs about 0.5% slower than someone standing still. At 50% the speed of light, your clock runs 15% slower. At 90% the speed of light, your clock runs more than twice as slow as someone on Earth. Metapause, Sex 1.0. And here's the ultimate case. What happens at 100% the speed of light, at the cosmic speed limit? Metapause, Sex 1.0. All of your motion goes into space, 100%, every bit of it. What's left for time? 0. At the speed of light, time stops. This is what happens to photons, those particles of light shooting through the universe right now. For a photon, no time passes, ever. A photon emitted from a star 13 billion light-years away arrives at your eye in what, for the photon, is an instant. 0 duration. No travel time. From the photon's perspective, it was born and absorbed in the same moment. The entire universe is frozen. The photon doesn't experience the journey. There is no journey. It leaves and arrives simultaneously. Because at light speed, all motion goes into space, and none remains for time. This isn't theory. This isn't speculation. This is measured, tested, confirmed. We've built particle accelerators that push protons to 99.9999% the speed of light. Their internal clocks slow down exactly as predicted. We've put atomic clocks on airplanes. When they land, they're behind clocks on the ground, by exactly the amount Einstein predicted. Time is flexible. Time is relative. Time depends on how fast you're moving through space. And that's not the weird part. The weird part is what this means for humans. Here's what this means for humans. Imagine twins, born on the same day, same parents, same birthday candles every year. One stays on Earth, lives a normal life, gets a job, raises a family. The other gets on a spacecraft, travels to a distant star at 99% the speed of light, then comes back. When the traveling twin returns, they've aged 5 years. Their sibling? 50 years. They meet as strangers. Same birthday, different generations. One remembers their twin as a young adult. The other sees someone older than their parents. This isn't science fiction. This is physics. The math is settled. The equations are proven. Only the engineering is missing. We don't have spacecraft that go 99% the speed of light, not yet. But if we did, this is exactly what would happen. The traveling twins' clock ran slower, not because the clock was broken, because time itself passed more slowly for them. They literally experienced fewer seconds. This is called the twin paradox, and it's not actually a paradox at all. It's just physics that feels wrong because your brain evolved on a slow-moving planet. Now, you might be thinking, we don't have light-speed spacecraft. This is all theoretical. Wrong. We deal with this every single day. Every time you use GPS, your phone is compensating for time dilation. GPS satellites orbit at about 14,000 kilometers, roughly 8,700 miles above Earth. They're moving at about 14,000 kilometers per hour, about 8,700 miles per hour. That's fast enough that their clocks tick slower than yours. But there's another effect. They're also farther from Earth's gravity, and gravity also affects time. Clocks tick faster when there's less gravity. These two effects don't quite cancel out. The net result? GPS satellite clocks gain about 38 microseconds per day compared to clocks on the ground. 1.0. 38 microseconds sounds tiny, but GPS works by measuring the time it takes signals to travel from satellites to your phone. Light travels about 7 miles, roughly 11 kilometers, in 38 microseconds. If we didn't correct for time dilation, your GPS would be off by about 7 miles within a day. By the end of a week, it would tell you you're in the wrong city. This isn't theory. This is engineering. We build this correction into every GPS satellite, every single day. Remember Interstellar? 1 hour on Miller's planet equals 7 years on Earth. That's not movie magic. That's real physics. The planet orbits a supermassive black hole. Gravity that intense warps time that severely. Christopher Nolan hired Nobel laureate Kip Thorne to make sure the math was right. It was. The equations in that movie are accurate. The black hole visualization was so precise that Thorne published scientific papers based on it. Time dilation isn't science fiction. It's the universe we live in. It's happening right now. To satellites, to particles in accelerators, to astronauts on the space station, although by tiny amounts. The universe doesn't care that your brain finds this uncomfortable. The universe just does what it does. We perceive time as having a direction. Past is fixed. Future is open. You can remember breakfast. You can't remember dinner. Why? If physics equations work forwards and backwards, and most of them do, why can't we remember the future? If you film a planet orbiting a star and play it backward, it looks perfectly fine. It obeys all the laws of gravity. But if you film an egg falling off a counter and breaking, and then play it backward, everyone knows it's fake. The yellow yolk doesn't leap off the floor, assemble itself into a ball, and seal itself inside a shell. Eggs break. They don't unbreak. Here's the secret. This isn't about time itself. It's about probability. It's about disorder. It is much, much easier to break an egg than to build one. Think about it. There are a billion ways for an egg to be broken. Scattered here, splattered there. Shell in 3 pieces. Shell in 1,000 pieces. Yolk mixed with white. Yolk separate from white. But there is only one specific arrangement where the egg is whole. Perfect shell. Yolk centered. Membrane intact. So as things move and interact, as molecules bounce around randomly, they naturally stumble from the organized state, where there are few options, to the disorganized state, where there are many options. We call this entropy. Entropy always increases. Always. In every closed system. Without exception. And this is the only reason you feel an arrow of time. You're watching the universe shuffle a deck of cards. You started with a perfectly ordered deck. Aces together, kings together, everything sorted, and every second that ticks by is just the universe shuffling it a bit more. You can't unshuffle the deck just by hoping. You can't unscramble an egg by waiting. You can't unbreak a window by watching. This means something profound. Your sensation of time flowing, that feeling of moments slipping away, is actually just your brain registering the increase of messiness in the universe. You're a disorder detector. When you distinguish the past from the future, you're really just distinguishing less messy from more messy. If the universe were in a state of maximum mess, maximum entropy, where everything was evenly spread out and nothing interesting was happening, your brain wouldn't be able to tell the past from the future. There would be no egg to break. There would be no memory to form. In a thermal equilibrium universe, the arrow of time vanishes. The flow of time you feel isn't fundamental. It's a consequence of the universe starting in an ordered state and gradually becoming more disordered. That's the arrow. That's the direction. That's why you remember yesterday and not tomorrow. Not because time is flowing anywhere, because the universe is shuffling. So the arrow of time comes from entropy, from increasing disorder. But here's something stranger still. Time itself isn't even the same everywhere. Your now and my now are not the same thing. If you and I are standing next to each other, our definitions of now are effectively identical. We look at a clock, we agree on the time. Simple. But what if you're on a planet a million light years away? And what if you start walking away from me? Your definition of now slices through the universe at a different angle than mine. This sounds impossible. Let me explain. Remember the car analogy? You're always moving through space-time at the same total speed, but how you divide that motion between space and time depends on how fast you're moving. When you move relative to me, your slice of now tilts. What you consider to be happening right now on some distant galaxy might be in my future. What I consider right now on that same galaxy might be in your past. Neither of us is wrong. Both perspectives are equally valid. #Meta. Sex 1.0. There is no universal now that covers the whole universe like a blanket. Think of the universe as a four-dimensional loaf of bread. The loaf contains every event that ever happened or ever will happen. Past, present, future, all baked into the same loaf. When you ask, what is happening now across the entire universe, you're slicing through that loaf. But how you slice it depends on how you're moving. If you're stationary relative to me, we make the same slice. We agree on now. But if you're moving, your knife tilts. Your slice is different. Your now includes events that are in my past or future. This is called the block universe. The universe isn't a stage where things happen one after another. The universe is all the events, frozen together in a four-dimensional block. Past, present, and future are just different regions of that block, different slices through the loaf. From this perspective, the flow of time is an illusion created by our limited view. We're like ants crawling along one slice of the bread, convinced that our path is the only reality. But the whole loaf exists, all at once, timelessly. This is deeply uncomfortable for most people. We want time to be special. We want now to be the cutting edge of reality, the moment where things actually happen. But physics says there is no universal now. There is only the block, and different observers slice it differently. If time is a measure of change, if events are just cards laid out on a table, #Meta 1.0. What happens when you run the movie backward all the way to the first frame? What happened before the Big Bang? This is the question everyone asks, and it's the question that might not have an answer. If the universe itself was born in the Big Bang, if space and time emerged from that event, Does it make sense to ask what happened before that? Here's an analogy that might help, or might break your brain further. Imagine you're standing at the North Pole. From there, every direction is south. You can walk south toward Canada. You can walk south toward Russia. You can walk south toward Norway. But you cannot walk north. Not because there's a wall, not because something is stopping you, because north has no meaning at the North Pole. The concept doesn't apply. It's not that north is forbidden, it's that north doesn't exist there. Now ask, what is north of the North Pole? The question sounds grammatically correct. It has a subject, a verb, an object. But it's meaningless. It's asking for something that doesn't exist. The Big Bang might be the same situation. If time began with the Big Bang, then asking what happened before is like asking what is north of the North Pole. It sounds like a valid question, but it might be geometrically, physically, fundamentally nonsensical. There may be no time before time began. This is the ultimate limit of our understanding. We are finite beings, trying to comprehend the infinite, using tools made of meat and electricity. Our brains evolved to track predators and find food. They did not evolve to understand the origin of time itself. It's a wonder we understand anything at all. And yet, here we are, using mathematics, running experiments, building theories that actually work. We've figured out that time is flexible, that it slows when you move, that it bends near mass. We've figured out that the arrow of time comes from entropy, that there is no universal now, that the universe might be a four-dimensional block where past, present, and future all exist. We've pushed our understanding all the way to the edge, to the moment before which there might be no before. That's not failure. That's not limitation. That's the most successful exploration any species has ever conducted. We are finite. The universe is vast. And we've mapped more of it than we had any right to expect. Consider the patterns again. The person who sees the tape measure versus the one hearing the voice. Physics is the same thing. Classical mechanics, the physics of Newton and Galileo, that was like the verbal counting system. It worked for day-to-day stuff, throwing balls, building bridges, launching cannonballs. But it had limitations. Just like the person who counts verbally can't read while counting, Newtonian physics couldn't handle certain problems. It broke down when things moved very fast or got very small. Relativity is the visual tape measure. It's a different mental architecture, a different way of representing the same reality. It allows us to process complex patterns that the old way couldn't handle. Moving at 90% the speed of light? Classical mechanics gives you nonsense. Relativity gives you precise predictions. Time near a black hole? Classical mechanics doesn't even have words for the question. Relativity tells you exactly how much slower your clock ticks. Here's the beautiful part. Even though your intuition is wrong, even though your internal clock is a biological hack cobbled together from whatever neural systems were lying around, even though time is a flexible, relative, bendy dimension rather than a strict metronome, it still works for you. You can still boil an egg. 3 minutes, done. You can still meet a friend for coffee at 2 p.m. You both show up at the same moment. You can still catch a train. The schedule is reliable. The weirdness of relativity is hidden under the hood. At the speeds you travel, at the distances you cover, at the timescales you experience, the differences are so tiny they vanish into nothing. Your broken clock works fine because you're moving slowly through a weak gravitational field on an ordinary planet. But isn't it better to know? Isn't it better to know that the engine is there? You can drive a car without understanding combustion. Millions do. But if you understand what's happening under the hood, if you know why the engine works, you're not just a passenger. You're someone who understands the machine. That's what physics offers. Not just practical tools, not just predictions, understanding. The difference between using time and knowing what time is. And that brings us back to that strange experiment with the counting. Remember the difference between the person who hears numbers and the person who sees them. Two people, same task, completely different internal experiences. Neither was wrong, neither was broken. They just had different mental architectures processing the same reality. That's what you've learned about time today. Your brain shows you a river, a flowing stream of moments, past receding, future approaching. Meta 1.0. Physics shows you something else entirely. A dimension, a measurement, a flexible ruler that bends when you move, stretches near mass, and might not even exist before the Big Bang. Time doesn't flow anywhere. Time doesn't do anything to you. Time is just the ordering of events, the bookkeeper, the scorecard. And yet, twins can meet as strangers. Same birthday, different generations. GPS satellites have to correct for time running differently in orbit. A photon crossing 13 billion light-years experiences 0 duration. The universe is stranger than your intuitions can handle. But here's the beautiful part. You can understand it anyway. Not by feeling it, not by intuiting it, but by thinking carefully, by running experiments, by trusting the math even when it contradicts your gut. That's what Feynman would tell you. Don't ask what time is in some mystical sense. Ask how we measure it. Ask what operations we perform. Ask what actually happens. And when you do that, the mystery doesn't disappear. It transforms into understanding. If this changed how you see time, even a little bit, drop a comment. Tell me which part broke your brain the most. Subscribe if you want more physics explained the way Feynman would have explained it. No memorization, just understanding. And I'll see you in the next one.